Welcome to Masterminds in Maintenance, a podcast for those with new ideas in maintenance. I'm your host, Ryan. I'm the CEO and founder of UpKeep. Each week, I'll be meeting with a guest who's had an idea for how to shake things up in the maintenance and reliability industry. Sometimes the idea failed, sometimes it made their business more successful, and other times their idea revolutionized an entire industry. Today, we're excited to have Steve Dobie here on the show, reliability engineer at Tech Resources, who's worked in the mining industry for the last 6 years. Welcome, Steve.
Thanks, Ryan. How's it going?
It's going great. I'm super glad to have you on the show today. Learn more about yourself, your background. Maybe we could start there. Do you want to just tell us and kickstart this off with a little bit about your background and yourself in this industry?
Yeah, for sure. So I'm a materials engineer from the University of Alberta. Some of my summers were done within tech at the mining industry down here. And after I graduated, I ended up taking the first job I could find, which like most engineers, we go into engineering to do design work. And so I did about a little over a year of design work and figured out that wasn't for me. So then I ended up getting a job with Fluid Life, where I really got my start in as a reliability engineer. Spent about 3.5 years there. Then I started working in northern BC at a mine called Red Chris Mine, which is 1,800 kilometers north of Vancouver. So it was a fly-in, fly-out shift work job. Commute took me about 24 hours to get to site, so it was quite the milk run to get up there. Only lasted about 8 months up there, and then I got my job with Tech doing similar type things, and Tech is just about 2.5 hours south of Calgary. So in a nutshell.
All right. So what are some of the most common problems that you guys are solving on a day-to-day basis at Tech?
A lot of it is just kind of understanding failure modes. We've got a lot of varied equipment. I work particularly with mobile equipment. There's a lot more going on with them. They're not necessarily more complicated, but they're moving around, so they tend to have a few more failure modes and a little less technology on them in terms of detecting those failures. So we're trying to figure out better ways to do that and better maintenance strategies to maintain the assets.
Yeah, I definitely know like the mining space is, extremely important to understand failure modes, because any kind of failure within that equipment could be catastrophic. So I definitely, obviously, way more about this space than I do, but I just could imagine the severity and importance of what you and your team do on a day-to-day basis.
Yeah, it's interesting because a truck is, you can think of it like a mini plant. It's just, it's the same things, gearboxes, pumps, motors, all the stuff is the same, just kind of, it's on tires and rolling around. The difference is there's, 100 of them, whereas you only have one plant. So if you lose one truck, it's not as big of a deal. So people kind of tend to take a bit of a more laxed approach to it, but the principles are the same.
Right. And I think that goes back to this idea when we talk about like failure modes, failure code, really about like the severity level of it. You could have the same piece of equipment, but in different plants, but the severity of something failing in one plant could be way more severe than the same piece of equipment in a different plant.
With mobile equipment, obviously you have operators in the seat of all of them. So there tends to be there's a big focus on safety everywhere. Yeah. But when you have somebody in the driver's seat, it can be a little more critical. Yeah. Operator could be in a little more danger if they do things incorrectly.
Absolutely. So Steven, how did you get into this space and this interesting industry of maintenance and reliability?
So I didn't realize it, but when I was doing my degree, turns out materials engineering is quite related. There's not many of us in the reliability world, but my degree focused heavily on failure analysis and the forensic engineering, which, when you start looking at RCAs, and that's a big component within an RCA, is that forensic and material side of things. Often underappreciated, but could be saying that because I'm a materials engineer. So, and then I did my design work, which I was doing design, and I didn't really design with reliability in mind. I didn't understand the concepts that well. And then when I started working in reliability at Fluid Life, I kind of thought, oh, this would have been great to know when I was doing some design work. So it's interesting that way. But at Fluid Life is really where I got started with it. They were an oil analysis company that wanted to be more of a reliability provider. So they brought in a team of a bunch of reliability engineers, Rob Kalrowski being one. I think he's been on your podcast a couple times.
Love Rob.
So I worked closely with Rob and a couple other people from lots of different backgrounds, and yeah, so definitely started my main learnings for reliability there, and have grown since then.
All right. That sounds awesome. That sounds like a, unique. I feel like every single person we bring onto the show just has their own unique journey getting into this industry. It never seems like a straight path, but I think that's what's also so beautiful about it.
Well, there's not many reliability or even maintenance engineering programs. I think the University of Toronto has a master's degree in it, but you've got your basic mechanical, civil, and if you're an engineer getting into it, you just kind of end up falling into it, it seems.
That's what we hear very often. So Steven, I would love to hear a little bit about like how you create maintenance reliability programs for the mining industry. What's a similar across all industries, and what's also unique to the mining industry?
So yeah, that's a great question. So when we're looking at so all the industries, they're really not that different, with the exception of maybe electrical stuff. Kind of gets into more things I'm certainly less familiar with, but the principles that how you apply reliability are certainly the same. But on the mechanical side, really, it's all just gears, bearings, varying degrees of how big and small they are, and so how you treat them really isn't that different. With a haul truck, with mobile equipment versus fixed equipment, you've got this extra thing bouncing down the road. Speeds are variable. Torque within the gears is variable. That's where you see a big difference. Like you'll get a lot of different kinds of fatigue failures within the mobile equipment, just because the loading isn't consistent. So if you're trying to follow like your regular fatigue curve for trying to figure out when something's going to fail, well, it's really hard to do on a mobile piece of equipment because it's loaded differently, and every mine has a different load factor. So things aren't apples to apples all the time. The mining industry really likes to think that everybody is completely different, but really, the different operation, you might just have a different failure mode that starts to rear its head versus one mine to another.
How do you account for that difference in load factor, for mobile equipment versus fixed assets?
Well, so for fixed assets, it's a lot easier to understand your load factor because it's running typically the same speed all the time. You'll get the occasional group that'll just design something to its maximum working pressure or whatever it is, instead of kind of looking at that efficiency curve. But in reliability, really, we tend to deal with whatever we're given. The load factors on like a truck, it really depends. If you're hauling uphill, you're going to have a really high load factor for that haul. So you tend to average it over the course of the haul. But the other issue is hauls change. Trucks are put on a different haul. Some are flat, some go uphill, some go downhill. So it varies a lot. With a lot of the sensors, you can actually just plot your load factor and watch it over time and see how that changes. And then usually we'll just take an average to try and make sense of it.
And I'm also curious, like how you take all these differences and implement that into a strategy. Like how is that similar across, different industries? And also how do you guys plan your strategy knowing all the differences within mobile assets?
So, we're trying really hard for the more so condition-based approach.
Yeah.
When you have such a variable load factor, you don't see the failures at the same intervals every time, depending on what's going on. And we all know as well. You look at the different failure curves. Things that follow actual wear out is pretty slim. Usually, your failures are from other things. So just trying to detect those failures beforehand and trying to understand what the life limiting factors are. So we've done a lot of good work at understanding, some of our major components. At the end, what's made them fail? What component is it? And can we take early intervention to either replace that component, or is it just cost prohibitive, just buy a new one? So we've taken some pretty drastic measures, and we've pushed out our component life quite significantly just by understanding what the end of life looks like.
Yeah, absolutely. So this kind of leads me into this next question here, Steve, is really showcasing the importance of maintenance and reliability. And it's very interesting because we talk about failures in a way that we know at some point a piece of equipment or a component within an asset is going to fail at some point. But our job as maintenance and reliability engineers is really to prevent that from happening. How do you showcase the importance of your guys' work, knowing that it is part of a piece of equipment's destiny that it will fail at some point? It
You know,
puts
I
you into a hard spot, right?
Oh, absolutely. It's, everybody wants everything to last forever. And there's actually a lot of things that, if you do some basic stuff, like you filter your oil, it can last a lot longer than you'd think it'd be able to last. But the biggest thing I find is predictability is more important, and understanding your distributions, your failure distributions, and your exchange distributions. So is there a particular point in the life where you're failing more of a certain component, and understanding what that looks like? And if you can reduce the variability within your components, not just looking at is this gonna fail, yes or no, it's really important, but we know it's gonna fail. Let's make them all try and fail at the same time, get consistent, because then we can operate in a planned fashion rather than reactive.
Yeah. I think you bring up such a good point, Steve, because I think people typically look at maintenance as just this like very reactive workforce, but I think the goal of reliability is to kind of flip that around, is to create a culture around predictability versus reactivity. And I think that's exactly what you're talking
Yeah,
about.
absolutely. And even the best companies in the world, it just takes a moment to flip back into the reactive mode. It's a comfortable place, particularly for maintenance people. You get rewarded by, something broke down, let's get it fixed quickly, instead of taking that step back and looking at why it failed and understanding that. And that's where reliability needs to step in and say, okay, yes, it failed. Let's take an extra couple hours of downtime, collect some of this data that's been lost, understand why it failed, so then it doesn't happen again.
I mean, it's so interesting, right? Like, because now we're taking extra hours of downtime to prevent a future failure. I'm curious, like, do you have any anecdotal data that showcases like how many failures you're able to prevent? And do you have some metric that you track that showcases, it was worth it to take an extra few hours of downtime because we prevented X, Y, and Z from happening in the future?
There's not, I don't know if I have a good metric to do it. It's just, I try and do like a cost avoidance kind of savings metric. That's also hard to justify. People don't always believe that as well. You say, oh, I saved $5 million. Sure you did. Where I don't see that money in my pocket. So it's an interesting game that you always have to play, and understanding that. A good executive team that has a good understanding definitely makes it easier. The best you can do is just try and quantify how many times it's happened in the past, figure out what the failure rate is or the mean time between that failure mode. And then when you solve it, you can look and say, look, we've got this extra uptime now that we've solved this issue. I made it sound a lot easier than I think it is, but that's what you have to do to try and justify it.
Exactly. And I know that that's a common thing that I feel like people in our industry have to solve and try to overcome on a daily,
Mm-hmm.
weekly, monthly, quarterly basis, is just like showcasing the work that we do and why it's important, improving it to ultimately not ourselves, it's to other people.
I find at sites, most places have a plotter. They're usually just collecting dust now, unless you have a department that really, like the mining engineers really like to print off maps and everything and use it. But I like to print off posters with just different KPIs, not even KPIs, just the performance indicators that maybe a mechanic would care about, like, and reward the good behavior and start driving a bit of a culture change. If something fails, don't just say, look, we need to do a full RCA. We need to, I need to take 5 people into a room for 3 days, really hash out what happened. You're not going to get any buy-in. It's about the baby steps. It's about, hey, yeah, this was a failure. Let's let's just run through a quick thought experiments. Let's take an hour, do a 5 why, just to kind of start building people into that way of thinking.
Yeah.
People don't like change. They might recognize that they need it, but it's hard. Everybody likes how they're doing things. When you bring new ideas in, you're often asking people to become busier
Yeah.
with the promise that they're going to be less busy in the future, which I don't know if that ever happens, but
Yeah.
that's essentially what you're asking for, right?
Yeah, absolutely. It's more like, you get less, well, you save in more productivity, but you get more work piled on you later as well.
Yeah, exactly. And then, somebody leaves and they're like, oh, this guy has all this time left. And, it's now you're stuck with everybody's work. And
So you mentioned having like these posters and showcasing KPIs across the team. What are some of the KPIs that you guys use and that you're a fan of?
I really like the scheduled versus unscheduled work or break-in work. I think that resonates with a lot of the tradespeople as well, because they don't like to operate in a reactive fashion. A mechanic likes to be able to plan out a job. If there's an engine changeout coming, they like to make sure all the parts are there so that it goes smoothly. There's a lot of them that like to do the diagnostics and stuff, but those guys, they get to do that. In mining, we have what's called running repair, which just goes out, and whenever a truck is or a unit is down for whatever reason, they jump on to try and solve the problem. If they can't solve the problem, then they fire it back to, then they bring it down to the shop and
Hmm.
try and solve it that way. So looking at that, mechanics really appreciate when they get to do things planned. They're not under a lot of stress. I think we can all appreciate that. Yeah, so that's one of the main ones I try. The other one I try to talk about too is how much savings. So especially if somebody does something good. At Fluid Life, I had this thing. It was called the Oil Analysis Save of the Month. Whenever we sent out an alert for an oil analysis sample and they took action, I'd do up a poster for them that talked about, okay, this is how much you saved by, you got the coolant out of the engine, you save the remaining life of that engine. Just by you doing that work, you saved the company $200,000. And whenever I can, I'd put names on who took action. Really try and give credit to the people who do it. That way, the next guy might want to get his name up there. And people really enjoyed that. I got a lot of really good responses from that. For lack of a better word, it's you got to put out the propaganda.
Yeah. Or, I think what I'm hearing too is just celebrating other people's success. And again,
Absolutely.
the work often goes unnoticed because something not happening in our industry is a good thing. So being able to celebrate the wins when something doesn't happen, when we don't have a failure, you predict a failure, like that is something to be celebrated. And I think for our industry, we don't see that enough. So it sounds like
Mhm.
that's really resonated with your team and done really well for you.
Yeah, for sure it has.
That's awesome. So, I mean, a good segue into this next topic here. I know that you are an expert in fluid analyses. Can you tell us a little bit more about what you guys are looking for when you're doing these, the importance? What are some of the key findings that you've found in the past and how you've been able to really drive the bottom line for your company?
Yeah, for sure. So oil analysis is just like any other. It's condition monitoring. The oil analysis people really like this analogy. It makes them feel more important than perhaps they are. But we like to compare ourselves to doctors. So the technician goes and takes an oil sample, just like you would go to a lab to get a blood sample taken. Lab analyzes it, and then the doctor gives you the results and what they think is wrong with it. That's the same thing we're doing for any asset. Oil really is the life of a component. If it's if the oil's leaking and there's no oil, it's not going to run. It's going to fail pretty quickly, just the same as your body would. But when you're looking at the results, what's really important is the trend. It's not about the individual values. We like to get hung up on, oh my God, this thing is flagged red, or the oil analysis results. People like to make them very colorful, and it's good, helps people read them. But what's really important is that trend. You know what? Even though it's orange and it's had 50 ppm iron for the last 6 samples, that's okay. You don't need to take action on it. It's orange. It's abnormal. I won't argue that. Odds are Maybe it's not going to last as long as some of your other assets, but there is nothing you can do to bring that down if that's where the asset runs. I've seen people go down crazy paths, down crazy rabbit holes, trying to solve an issue that just isn't there because that asset, for whatever reason, is running at a higher rate of metal in there. So it's important to look at that. And a lot of people get really inundated with bad results. I've seen people with 90% of their samples come back flagged, and it's hard to sort through that and understand what's actually a problem. So that's when you really have to stop looking at the individual samples and then more so look for themes. The first thing you want to make sure is your data quality good? Are your samples being compared to the right things? Mobile equipment, more specifically, because 930E Komatsu truck should be compared to other 930E Komatsu trucks. So make sure that everything's labeled correctly. But then you got to start to pick out themes within the oil analysis. Is a lot of your flags coming from viscosity? If it is, then maybe you have a problem with tradesmen incorrectly topping up oil, or maybe if you're in the natural gas industry, you probably just have air entrained in your oils. That's a common issue, and like it's hard to sort through everything. So just start picking out themes. That's really the best way to do it.
When you think about like condition monitoring, it's not just the beauty of condition monitoring is the trends over time, the themes over time. It's not just the single snapshot at one period in time. And I think that's what you're getting at is the importance of looking at how it's been trending over several periods versus taking that 1 or 2 or 5 different samples and reacting to that.
Yeah, absolutely. And like an engine is a perfect example. When you're trying to figure out, you have 5 engines, they all need to be changed. Okay, how do I figure out which one to change? Because there's no way I can do 5 engines. You can look at your sample history and understand, okay, what did I see? You think about what's life limiting within an engine. It's coolant, it's fuel. Those are the 2 main things. Okay, which one saw most of that throughout its life? Okay, if there's one that really stands out, okay, let's do this one first. If there's another one that hasn't seen that at all, at that one, you could probably let her buck for a little bit longer until you can, when you have a little more time to solve the problem.
Any recommendations for our listeners on tools, technology, advice for doing, fluid analyses, especially those with limited resources to be able to like analyze all of the data and results?
Your tradesmen actually probably know a lot of this already. I know in Canada, our Red Seal mechanics actually have an oil analysis component to their journeyman ticket. I'm not sure if it's the same in the US, but they typically know what everything's made out of. They know how things work. So if you bring a result to them and say, look, I don't know what I'm doing, they're going to probably have a good idea how to troubleshoot it because they've done it before. A lot of people like to think engineers know how to maintain things. We really don't. We just kind of, we talk to mechanics, we read the instructions, and we kind of fumble our way through. We have an ability to learn. I'm not saying nobody else has an ability to learn, but we're not quite as valuable as necessarily the tradesman that's sitting on the floor that knows how to do the job. So that's a great place to start. There's also your lab. We'll have a common list of where things come from. I kind of hesitate asking your lab. They can also be good with helping sort out which samples are a problem sample, or kind of help you with database issues. But then there's also some third-party companies that offer consultants. Dingo's one. Some people really like them. They're a bunch of mechanics that just like to help on oil analysis, and there's a few other companies like that as well. So there's options out there. Big thing is, take a training course. They shouldn't be all that expensive. I know there's lots of companies that offer it. Noria is a great resource. When I was at Fluid Life, I was regularly on the Noria website. When people ask me questions, it's the first place I went. So they're a fantastic resource if you don't have a lot of money to spend either. So.
All right. So what I heard is utilizes the resources and people that you already have, because the answer could be right in front of you. It's just accessing them for that knowledge. That seems easy to do, Steven. What's something you wish more people knew about maintenance and reliability?
My biggest thing is, what's the difference between maintenance and reliability? We see a lot of reliability engineers doing maintenance work, maintenance engineering tasks. Reliability engineers shouldn't be involved in the day-to-day. Even looking at a condition monitoring samples, this is one I've kind of argued with people about, but if you're looking at a sample and creating a work order, that's a maintenance activity. Reliability often takes that on because they seem to understand the condition monitoring, but ultimately you're doing something to maintain the asset. Reliability is about looking longer term. Best practice is to not even have it as part of a maintenance department, because especially in the mining industry, your operators have such a strong effect on the reliability of an asset. Is that operator having a rough day? Is he, taking corners a little tighter? Is he, there's so many different ways you can operate a truck that's driving down the road that's going to impact the reliability of an asset. So if you're outside of that realm of maintenance and can take that operator driven reliability approach, you're going to have a lot of success, because that's where a lot of failures happen, is just machines are being operated inconsistently, and like looking for a way to bring everybody and teach the operators. I loved giving training courses to the operators. Like at Red Chris, I'd go out, let's talk about tires today. Let's talk about what makes tires fail, teach them how it works. And they love it. And it changed the behavior. Some of them, there's always the person that you might not get through to, but you can change a lot of people's mind, especially, engineers. We always get this, engineers, what do they know? So it's, and I think I said it earlier in this podcast too. So getting out there, getting in front of people, telling them how things fail, how things work. People love to know how things work. We all loved building with Lego as kids. So
That's awesome.
yeah.
I will press you a little bit on this. Maintenance and reliability, yes, two different functions within an organization, two different like types of brains. One is thinking about the short term, one is thinking about the long term.
Mm-hmm.
But I guess the question that I'd have around that is like, in order to tell the full story of an asset, you have to know both, right? You have to understand what's going on today, and you have to understand what will happen over long periods of time. My guess is if you completely separate the two departments, they become more siloed, and you don't get to tell that cohesive story as well. So I guess the question for me, Steve, is how do you like give reliability the space and time that they need to really think long term, but also incorporate, the very important aspects of what's happening today?
Yeah, that's a great question. And I think that's exactly why they're often, or most, I don't know if I've actually been to a place where they were a separate department. There is definitely a very fuzzy line on where it's different and where one begins and one starts. And I like the ISO 55000 standards, asset management. When you read them, it's hard to get a lot out of just reading those standards. But when you start looking at the IAM and some of the documents they've put out, they really help kind of bridge that idea. And it's about really we want to understand what the life cycle is, how to totally understand what that asset looks like from commissioning to decommission. Nobody that I've seen truly understands that, because all of a sudden you get to the end of the life of an asset and it's I think we need this for another 5 years. And so the plans are gone. And so, a disciplined asset management strategy can definitely help kind of guide that. And then silos are important though, in a way. You just need to have good communication between them.
Yeah.
And if maintenance and reliability are separate silos, then they just happen to need maybe a bigger bridge between the two. Make them work in the same office. But ultimately, like, there is maintenance and operations tends to not work well together. That's not standard across everywhere, but the age-old problem.
Yeah.
And reliability is a perfect way to get somebody in the middle, facilitate that communication, and bring everybody to the table and make the assets run as effectively as possible.
That's cool. I do like that idea of reliability being the bridge between operations and maintenance, because we have heard that as a common theme across many different companies. So Stephen, where do you go and where do you look for other resources to continue learning, improving, and honing your skill? Where do you go for new ideas?
Well, an inherent part of reliability is a lot of mindless data entry and just kind of, getting your stuff into a usable format. So I tend to listen to podcasts as I'm going through that. I don't always listen to the reliability podcast. I have some junk podcasts in and around there to help
What
me
do you
get through it
listen
all.
to?
um, I like a lot of history stuff, so I'll listen to a few history podcasts. I've listened to there's a couple comedy ones. I can't remember the guy's name at the moment, but Joe Rogan. Sorry, I've listened to his
Yeah.
a few times. But then there's other maintenance reliability podcasts. I've listened to a few of yours and Rob's we talked about earlier, and there's a few others out there that I'll turn on. But for a more structured approach, I actually go to edx.org. I do a lot through there. They've got a lot of great courses, and they're either free, and if you really like certifications and getting credit for things you do, you can pay a fairly small amount. So I've been going through them. I'm actually doing my Six Sigma through them. I really, really like that their platform.
What do you think of Six Sigma? It sounds like you found a lot of value from it. You're going through the course right now. Is that something you think everyone should do? Being in this space.
It's funny because Six Sigma is kind of it's an old concept. With all the exciting things that are out there, the machine learning and a lot of these other advanced analytics, we forgot about the basics.
Mm-hmm.
And Six Sigma goes in to kind of the basics and understanding what does quality mean. I've pushed back on some of our vendors that, they're manufacturing a product for us, yet they're not following basic Six Sigma rules. So how do they have all this cool advanced analytics that they're doing, but they're not understanding simple quality type concepts. So, I think it's hugely important, and it's applicable even if you're not in a manufacturing industry. It's hugely applicable.
So Steve, I really enjoyed this conversation with you. I personally learned a ton. Can you share with our listeners on how they could connect with you and all the different ways they can?
Yeah, the easiest way is going to be LinkedIn. I'm on there fairly regularly and try to post the occasional insightful thing. But yeah, that's really the best way.
That's awesome. Well, I really appreciate you opening up your door to helping out others as well and supporting the community. It was amazing having you on today's show, Steve. Thank you so much for joining us. Thank you to all of our listeners for tuning in to today's Masterminds in Maintenance. My name is Ryan Chan. I'm the CEO and founder of UpKeep. You can also connect with me. I'm pretty active on LinkedIn, or you can also email me directly at ryan@onupkeep.com. Until next time, thanks so much again, Stephen.
Thanks, Ryan.